Okay, hello everyone. We'll see you again. So today we talks about some problems about the duduced rate. So we know that there are various kinds of fluid in the different research and engineering areas. So in our daily life, the most general fluid are air, water, and honey, etc. Compared to honey and grace, air and water are lowly viscous and easily transfer into the irregular motion. Although ideal fluid do not really exist except for some fluid in special conditions, viscous flows, which inertial force is dominant, may be treated as nearly ideal. So for the unsteady incompressed flow, so equation of continuity also can be expressed as this flow, as this equation. Okay, so and although that the most general forms of the NS equations would be in this field. Okay, so this will be Navier-Stokes equation. And we know that for higher value of by means of the non-dimensional numbers, the Ronus numbers, the viscous fluid can be characterized quantitatively. So the Ronus numbers, okay, so it's a ratio of the advocative terms to the viscous term, right? So which can be used to as the measure for different flowing state of the fluid. So this is Ronus number, and we know that for higher Ronus number, if it is higher than the 1, so the effect of the viscous force on the flow behaviors can be neglected, right? So now we would say that the flow, we could call it the potential flow. Okay, so therefore, so the leaving out the viscous terms, we obtain the following equations for unsteady impressed potential flow. So this one, okay, so would be, okay, I'm sorry, and then this would be the unsteady incompressed incompressible potential flow. Okay, so so the equation of the continuity can also be expressed in this term, right? All right, so so we know that in this expression, so the barotropic equation of state would be equals to, right? So a closed set of 5 equations, I mean this 5. 1, 2, okay, 3, 4, and this would be 5. So these 5 equations for the 5 field. So we could obtain the pressure, density, and velocities can be obtained if we assuming that the G is known. So if the equation of state also depend on the temperature, if we depend on temperature, so this would be equals to, okay, so right, okay, an equation for this temperature field can also be added to this set. So however, the fundamental equation for ideal fluid are used to solve this flow problem of the real flows. But when the viscosity of the fluid is higher and the viscous force become more dominant compared to the inertial force, so the effect of the viscous force on the flow behaviors cannot be neglected. So in such conditions, so this assumption for the fundamental equations is no more adequate for the real fluid. So thank you.